Let's do problem 4.8, Twitter users and news, part 1. A poll conducted in 2013 found that 52% of US adult users got at least some of their news from Twitter. The standard error for the estimate was 2.4%, and a normal distribution may be used to model the sample proportion. Construct a 99% confidence interval for the fraction of US adult Twitter users who get some news on Twitter and interpret the confidence interval in context. Please round all percentages to 2 decimal places. Okay, so what we need to do is we need to think about how do you construct a confidence interval in general, and then we'll use the information that was given to us to construct this specific one. Okay, so to construct a confidence interval in general, you take whatever your point estimate is, and then you add and subtract from that whatever the value of z star is. That's the number of standard deviations that you want to move on either side of it, times your standard error. Okay, now we don't need to do any calculations for the point estimate, nor do we need to do a calculation for the standard error, because both of those were given to us in the problem. What we are going to have to calculate, though, is the value of z star. So let's do that, and then we'll go and put the whole thing together and see what the confidence interval looks like. So they told us that we can go ahead and use a normal distribution to model this. Well, that's good, because then that means that the sampling distribution will be approximately normally distributed. And then the distances, the number of standard deviations away from the mean, can be calculated by using the z distribution, because that's what z gives you. It gives you the number of standard deviations you are above or below the mean. So now they want a 99% confidence interval. So what that tells us is that 99% is in the center of this distribution. In other words, this is 0.99 from there to there. All the blue stuff here is 0.99%, okay? Or 99%, excuse me, which is 0.99 as a decimal. All right, so that's not what we are going to have to put into the calculator, because the calculator uses the left tail to figure out what those z star values are, okay? Corresponding, since this is symmetric, the right tail is going to have the same area. So the thing to notice is that you have 99% of it taken up in the center. So to figure out what those red areas are right there, well, the two of them together, this one plus this one, both have to come to 1%, don't they? When you think about it this way, if I take 1 and I subtract 0.99 from it, what I'm going to get back is 0.01, which is equal to 1%. And that totally makes sense, because 99% plus 1% is 100%. But the thing to notice is that it's not 1% in this tail and this tail, because that would give me 101%. That'd be too much. I have to split this in half. So half of this 1% has to go in the lower tail, which is going to be 0.5, or a half of a percent. And then the upper part would have the same amount. It'd be 0.5%. Okay, so if you take 0.5% and we convert that into a decimal, that's going to be equal to what? 0.005. Okay, now that's critical. Make sure you understand how I did that. I moved this decimal point, what, 2 places to the left to get rid of that percentage symbol. Okay, cool beans. All right, so now that we've got that, we're going to be able to take that number and put it into our calculator, because the calculator, if you give it an INV norm, the left area that you're looking for, in this case 0.005, and then you give it the mean, which is 0, and the standard deviation, which is 1, because we're working with, remember here, this is n of 0 by 1. It's the standard normal, okay? Then that's going to give us back this value right here. In other words, it'll tell us what that number is. Now it's going to be the negative value of it, and then because this is a symmetric about 0 here, we'll get the positive value by simply just changing the sign. In other words, this distance right here is going to be the same as this distance right here, just this number down here is going to be negative, and this number up here, these should be on the axes, is what I'm trying to get you to look at, by the way, that one will be positive. Okay, so let's get the calculator in here, and let's actually go ahead and do that. Enough yakking about it here. Let's get my calculator up. Okay, so let's get the calculator down a little bit so you can see her a little better here. There we go. Okay, so what are we going to do? We're going to go second distributions. We'll go down to option number 3 for IV inverse norm, IVN norm, and we're going to put in area as 0.005, and then we're going to put in the mean is 0, and we'll put in the standard deviation as 1. Now notice that in the fancy schmancy calculators, it pastes the command to the home screen. If you're on an old school calculator, you've got to type that 0.005, comma 0, comma 1 in, and then close off the parentheses. Okay, so once I've done that, if I hit enter, it gives me back negative 2.57. We'll round it off to 3 places, 576. Typically what you do is round these off to 3 places, okay? So that's equal to, let's get my pencil back here. Let's get the calculator back up again so we can keep it up here with us. Here we go. So there we go. That's going to be equal to negative 2.576. All right. Now what that is, that's this number right here. It's the lower value, okay? So the upper value right here, well, that's going to be positive 2.576. This lower value down here is going to be negative 2.576. So that's the plus or minus part right there, okay? Alrighty then, awesomeness. Okay, so let's get a fresh piece of paper here and let's see if we can actually construct the confidence interval now. So if you recall, what they told us was that the point estimate was 52%. So we'll just stay in percentages here, okay? So that's going to be 52% plus or minus our z star, which is 2.576, times, now they gave us a standard error. We don't know how to calculate that yet for proportions, but it's no big deal because they gave it to us. They told us it was 2.4%. Okay, now the thing to remember is that that notation right there is two numbers. The lower bound, or the lower part of the confidence interval, is 52% minus 2.576 times 2.4%. And then the upper bound of it is going to be what? Well, it's 52% plus 2 point. Let's go ahead and get rid of the calculator here. 2.576 times 2.4%. Okay, so that's the interval. Notice that is the lower part of the interval and that is the upper part of the interval right there. Okay. All right, so let's go ahead and actually get the calculator back here for a moment and let's go ahead and do that calculation. So let's clear this out here. So how are we going to do that? We're going to go in and put 52. Let me slide it down just a smidge so it's out of my drawing for you. There we go. So we'll put in 52. Still got to keep the keyboard though. Let me get it in the right spot. That'll work. Okay, so we'll take 52 and then we'll do the lower end. So we'll go minus 2.576 and then times 2.4. And we do that, that gives us the lower number, which is 45.8176. Okay, so let's write that down. So that's 45.8176. Okay, that's out 4 places. We don't have to take it out that far, but we'll do that for just the moment. Okay, we'll round off here in a minute to get the proper number of decimal places that they were looking for, but we'll do it like that for now. Okay, and then now we got to get the upper number, which is going to be, well, that's 52 plus 2.576 times 2.4. We hit an enter, and that gets us 58.1824. Okay, so they ask us to round these numbers off to 2 decimal places. So rounding it off to 2 decimal places, the interval would be 44.82 up to 58.18. Okay. All right, I'm going to let you answer the remaining question on this particular problem where they ask you to interpret the meaning of your confidence interval. If you need to review that, look at the earlier problems. There's a nice connection to Khan Academy where they go through a nice lesson reminding you how to do that. And there's also some links to where to go read about it in the textbook.